This is problem solving tip 4.1. It shows you a general strategy for carrying out stoichiometry calculations. Let's look at the general approach, and then we'll look at a simple example. In many cases, you'll be given a given mass of some reactant, and you'd like to find out how much product is formed in a chemical reaction starting with that reactant and, let's say, unlimited amounts of some other reactant. The main thing to realize is that a direct calculation is not possible. You cannot go directly from the mass of one thing to a mass of another. Instead, we have to remember that chemical reactions happen molecule for molecule or mole to mole. And so we have to take an indirect route using amounts of material and not their masses directly. So the first thing we'll do is convert our mass of our reactant into an amount of reactant. Then we'll relate that to the amount of product that can be formed, and only then can we calculate its mass. The really important step in this calculation is the one here in the center of the diagram. That's where we use the stoichiometric factor in our calculations. Stoichiometric factor always takes the moles of reactant, multiplies it by the moles of product that are formed in the balanced chemical equation, divided by the number of moles of reactant that are used in the balanced equation, and that gives us then the moles of product from which we can derive the mass of product. Okay, now that you've seen how to carry out a stoichiometry calculation in general, let's take a simple example. We're going to start with 14 grams of nitrogen, and we'd like to know, given unlimited amounts of hydrogen to react with it, how much ammonia can we produce from this reaction. Well, the first step is to convert the mass of nitrogen into an amount of nitrogen, and we'll do that by starting with the molar mass of N2, 28 grams per mole, and that gives us a half mole of N2. Now comes the most important step in the calculation. We need to use the stoichiometric factor. If we go back to the balanced chemical equation, we see that there's 2 moles of ammonia produced for every 1 mole of nitrogen that goes into the reaction. So that gives us our stoichiometric factor. We know that there are 2 moles of ammonia produced for every 1 mole of nitrogen that goes into the reaction. So if you multiply the amount of nitrogen available, half a mole, by the stoichiometric factor, you'll notice that units of moles cancel out, moles of nitrogen, and we're left with the amount of ammonia produced from the reaction, 1 mole of ammonia. Well, the problem is essentially solved. We can find the mass of product now by including the molar mass of ammonia, 17 grams per mole, and we find that 17 grams of ammonia are produced, starting with 14 grams of nitrogen. Well, this is a rather common kind of stoichiometry calculation, and you will see many more of them in the course of studying chemistry.